Sorry for the my video got disconnected in between something. So now again I will start. What is primary and what is secondary. If the first coil in which electric energy is fed from AC supply mains is called primary, okay, and the other from energy is drawn out is called secondary side, okay. So the principal transformer has some particular rules, and these rules are what are the how these transformers are made. So it transfers electric power from one circuit to another. It does so without a change of frequency. It accomplishes this by electromagnetic induction, and where the two electric circuits are in mutual inductive influence of each other. Okay, so these are the transformer characteristics. Okay, so now what is the construction of a transformer? So it is clearly shown in this diagram that how the transformers are made. So you can see in the primary coil side the number of turns are very less, but in the secondary coil side the number of turns are very high. In the second picture, the primary coil has more number of turns rather than the secondary coils. Okay, so these are the two types of transformer constructionally. That means one can be step up. Step up is the first one. First picture is used for the step up transformer, and second picture is used for the step down transformer. Okay, so these are the two types of constructional transformers. So now we will move forward, and then you can see that what are the types of cores used for constructing a transformer. Okay, so here you can see in figure number 32.5 there are some alphabets E, L, mirror L, I. So these are actually cores. These are the types of the core which is used for making of a transformer. Okay, so now these cores will be laminated to minimize the error or to minimize the leakage flux from the transformer, or to minimize the minimize the error due to the flux leakage. Okay, so this is one method to minimize lamination is one method to minimize the error in a transformer, which I will be discussing elaborately in the next section. So now cores, these are the one more classification of transformer. This is core type transformer, and one different type transformer is shell type transformer. This is the manufacturing classification, how the transformers are manufactured. Depending on that one, it can be one is core type transformer and the other one is shell type transformer. So in case of shell, this L and H, L means low voltage side, H means high voltage side. Okay, so low voltage, high voltage, low voltage. So in case of shell type, this is the transformer cores will be working as a shell. Okay, so now in case of core type, the transformers will be the transformer cores. You can see that HV-LV. HV-LV means a insulating cylindrical type of cores are used for the core type transformer. Okay, and in case of that means the coils will be wounded on the cores. Okay, the coils. Okay, so and in case of shell type, the coils will be inside and the core will be covered from the outside. Okay, so now again I will move forward to the major part. Sorry. Now again I will this one. Now I will move forward to the major part of this topic, that is EMF equation of a transformer. So how we will find the EMF equation of a transformer? As I have already told you that there are two sides of transformer, primary side and secondary side. Okay. So to find out EMF equation, we have to go through which side we are calculating, which side we are taking for step up and which side we are taking for step down. So here it has been calculated that it has been taken that N1 is less than N2. Okay. So now here N1 is the number of turn in primary side, N2 is the number of turn in secondary side. Phi M is the maximum flux in core in Webers. And you can remember that phi equals to Bm into A, which I have discussed in the previous videos. Okay. So F is frequency of AC input in hertz. So now in figure 32.14, we can see that the flux increases from its zero value to maximum value of phi m. This is the maximum value of phi m. Okay. So now the flux increases from zero value to the maximum value, zero value to maximum value of phi m in 1 quarter of the cycle, that is at 1/4 f second. Okay, 1/4 f second. Okay, that means why f is coming downward, because all of us we know that T is inversely proportional to f. So now average rate of change of flux is phi n by 1/4f. So that means 4f will move to numerator side. Okay. So we can get that 4f phi m Weber per second or volt. This is for the average. So now the rate of change of flux per turn means induced EMF in volts. That means average EMF equals to 4f phi m. Okay. So now if flux phi varies sinusoidally, so then the RMS values of induced EMF is obtained by multiplying the average and with the value of the form factor. So now all of us we know that how to find out the form factor. That means RMS by average equals to 1.11. So now what is the RMS value? As whatever we are using for domestic purpose or for the industrial purpose, we always calculate with the value from RMS values. Okay. So to convert the RMS value, what we have to do, we have to multiply it with 1.11. So now the RMS value of the for the EMF, generated EMF is 1.11 into 4f phi m. So that means 4.44 f phi m volt. So that means E1, that means the induced EMF in the primary side, E1 equals to 4.44 f N1 phi m. So that why this N1 has been calculated, because at first it was said that for a single turn if the induced EMF is that much, so that means for N1 number of turns what will be the total number of EMF generated. Okay. So if as I have done this one in video lecture, I will discuss this one in team also. So now I will stop the video and then I will share it in YouTube. Thank you.